Okay, so we have a MacBook Pro. It's a low power. It's a A1398. Uh, yeah, that's model number is A1398. As usual, the back screws has already been taken out, and also the client took out their drive, so there is no drive, and also there is no the IO board cable is also not present. So first thing we want to do is to disconnect the battery, connect our charger, and then define what state the machine is in. For these machines, it is ideal to use an 85 watts, not a 45 and not a 60, 61 or 65. So if you're going to use a 65, because it's an A1398 15 inches, you need to have power on your battery. So usually there's what I refer to as power balancing, where if you have a bit of power on your battery, that will balance out the shortfall of the power that will come from the charger if you're using a lower rated charger. But then if you have an 85 watts, then that will suffice. You do not have to worry about having to get um, uh, power from your battery. So that said, and then also this is a 2015 A1398. One of the ways you can differentiate between the 2015, 2013, and 2014 is the trackpad cable that goes over the trackpad. So the 2013 and it's a similar form factor. That's the outer design. It's similar. The screen size and everything is the same thing. However, when you open up the inside, but even the SSD that I used across 2013 to 2015 are the same thing. However, the trackpad design is not the same thing, and this was the first time, other than the 20 on the 15 inches line. This was the first time Apple introduced the haptic feedback, and then also if the machine is on, you will also realize that the response on the trackpad is not the same as the older designs. So that's one of the ways you can basically differentiate between the 2015 and 2013, 2014. Okay, let's connect our charger to see what we have. Okay, so charger is connected, and then we have communication on the charger. Uh, we do not necessarily expect to have full fan spin because it's a 2015 also. The designs of the fans are not like the previous design where the fans will start immediately the machine is in SL state until the machine goes into S5, which is off. So with this design, what will happen is the fan will only kick in when the CPU gets really, really hot. So yes, we have confirmed that we have charger communication. So let's see what we have on our PP bus. By the way, let us open up the board view. This is an 820.00138. Let's open up the board view. 820.00138. Uh, 820.00. We can also use 0016. Nah, no, not this one. We can use, in case I don't find it here, we can use something similar to it. Okay, let's check here. 00165, 850, 2824. Okay, here we go. This is the board view. Okay, so let's see what we have on our PP bus because we don't have to worry about PP3V42 because we have charger communication. PP3V42 is present. The next thing we want to see is what we have. Let's see what we have on our PP bus. PP bus we can measure at our fuse here. Two fuses here. Here we can get our PP bus voltage. So F7141 and then F7140. Let's see, we're expecting to have 12.6 on our PP bus. Let's see what we have. 12.56, yeah, that's about it. That's fine. PP bus voltage is present. Okay, that's good. Let's see what we have now. 5 volt. Okay, so 5 volt, that's an SO rail. We're getting 5 volts there. Means the device is partially starting. So this device is partially starting. Uh, let's check that. Okay, so we have an PP3 before too. And then PP bus, source rail, that's fine. 5-volt line, that's fine. Okay, so the device is partially starting. What we now want to do is take the board out and then check the other side of the board. The device is in SO state, which means the device is not completely dead. Just take the board out, check the other side of the board, and then identify why the board is not completely started. But we have SO rail, which is a good thing. Okay, board is out. Let's put the shell on the other side. Flip the board to the other side. Okay, so here it's our problem. So we see when we flip the board to the other side, we have an issue about E7501. So E7501, I'll show you guys, that is a 5-volt, 3-volt line. Let's open that up. H0-00163. Okay, there we go. E7501, E7501. So U7501, it's say here it says 5-volt, 3-volt power supply. Now we see we have two outputs, which we have one inductor here, which is a 5-volt output, PP3 underscore S5, and here it says 3-volt. That's the output that you're supposed to get, and then the other one you're supposed to get. It's supposed to get 5-volt. Here it says 5-volt. So let's go to L7520, and then see what we have on the output. So we come here and then we search L7520, and then the other output is going to be L7560, L7560. So we need 3.3 volts there, and then we already checked that we do have 5 volt there. Let's check our 3.3 volt. Connect our charger. Flip to the other side. See if we have 3.3 volt. So that inductor is going to be this one here. That's the inductor, which is L7560. Let's see what we have. We have 3.3 volt. Let's see, is it stable? 3.3 volt is stable, and then the other side obviously will get the same thing. And then we already checked that we have 5 volts there. Let's just check again. We have 5 volt. Is it stable? Yes, it's stable. Then the other side, 5 volt is stable. Now on the other side of E7501, let's see what these are. This is where our issue is. Aha, so that's the current sensing line. Now, so that is where it says CS. So that's the current sensing line. The chip itself needs to U7501. Let's go back to pin 7 of let's go to, so that's the pin 7. So CSP1 and CSN1. So that's the current sensing line, which is the 5 volt S4. Uh, Having an issue there will obviously prevent U7501 from attaining full functionality. So what you want to do is address that section of the board. Hopefully, we should be able to get somewhere with that. Okay, so we seem to have um, a damaged part that will be addressed. Okay, now we need to get a donor board. It's on the donor board. Okay. so that is done. We expect the board to start now. However, there's still a bit of work to be done on this section of the board. Okay. Next, it's here. Okay. Okay. Scan that section of the board. Let's check. Check it right there. Just I need to get the board into test it. We're not closing the machine yet. Okay. Uh, okay, so we have let's see. J6050. Let's check J6050, J60, J6050. Uh, 509. See where that is being generated. Okay, it's been generated at Q7060. Okay, and let's see if this 5 volt line is present on an S4. Let's see if that's present. Yes, that's present. Okay, so let's quickly take the code out so we can go to the other side and see where that load is being generated from and why we are having less than 5 volt instead of having 1 volt instead of 5 volt. Q8060. Let's check for Q8060. Q8060. So that's Q8060. Let's go to the other side. Q8060. So what we have. 5 volt is present. It's fine. Let's check the output. 1.0. Okay. So let's say getting 1.0. The enable signal Q8055. Let's check the enable. New signal. Let's say if the chip is being asked to turn on pin 2. Let's see what we have on our pin 2. Okay, we have 3 volt on pin 2. Let's quickly see, do we have a short on that line? Let's see, do we have a short on that line? Okay, we don't have a short on that line, that's good. PM sleep is 4. PP3, it's steady and present and steady, and then another signal, present and steady. So in 2, okay, let's see. Yeah, let's see. So actually, yeah, 5 volt it's fine now. But just to be it's just to be safe, let's check it here. Let's confirm this. Let's see if we still have continuity there. Okay, that's fine. See what we have here. Unfold. Let's see. And 3 volt is present, ground. Okay, let's see the present. 5 volt. 0, 4, 0. let's give in another one. So we are getting 1 volt instead of 5 volt on an SO 5 volt power line. And what we again had to check, see if we have the working condition of U7060. We did check. We have a 5 volt line, and then we also have our enable signal. If we check here, so we checked here PP5 SOEN that is present. So which means basically this is opening, and with this opening, we're supposed to this is supposed to also open to give us 5 volt, but we are getting 1 volt instead of 5 volt. So we are going to replace it and see what we get afterwards. Okay, let's clean that section of the board. Okay. See if we still have if we still have 1 volt. Oh, let's see if we have 5 volt now. We're expecting to have 5 volt here, which is this cap here, the pin 2 of that cap. Initially, we were having we're getting 1 volt. Let's see if we get 5 volt now. With 5 volt, the board should start. If we get 5 volt on that day. Yes, now we have 5 volt. So the board should start in this state. So initially we were getting 1 volt at Q7060, and definitely that will not allow the board to start. But now we have a 5 volt, so that with that the board should be starting. Okay, as you guys can see, we have a fan spin. So let's make a quick summary of okay, first of all, let's just see if we have Apple logo before we summarize the repair. Let's connect our screen. We're not expecting to have Apple logo because the drive is not present, but then we will get a question mark folder which indicates a missing boot part. Okay, let's see if we have question mark folder. Okay, so that's it. We do have a question mark folder. That's it. This is a completed repair. I'm just going to go over what we did so we can make sense of it. So the board itself, it's liquid damage. There were sections at random on the board that had corrosion. The first thing we saw was an issue by E7501, which is a current sensing line over PP5 volt underscore S4 underscore, which is so we did address that, and then after we address that, we also address this section here, which is Thunderbolt. This section here, it's not really relevant to the current state of the machine. Now, before we came here, we actually our measurements showed that the board it's partially making its way into SO state, but obviously because the working conditions, the required voltages are not complete, we were not getting the fan speed. So we replaced these caps, and that was not relevant to exactly the repair, but then just as a preventive measure to avoid a short on those caps, resulting from those caps in the future. So we replaced those. And then we then had to replace C7518 as well as R7547. That did not solve the issue. So when at Q8060, so we were getting 1 volt on the 5 volt line. So we what we had to do was we couldn't just blame 80 Q8060 right away. So because in order for Q8060 to function, it requires so the working conditions for Q8060. So in order for Q8060, so Q8060, as we see, this is the source that is we have the gate and then we have the drain. Now this is a P channel type MOSFET, and then the output is 5 volt obviously. However, we were getting 1 volt at output. Now, in order for this to work, we need source. If the source voltage is present, and then the gate, and then at its gate is being allowed to open, which is going to be determined by Q8050, then we'll get an output of 5 volt. However, when we checked, we were having our source voltage at pin 123, and then our gate also at our gate at Q8050, we were also having our enable signal. Now, we this so what's going to happen is when this enable signal is present, then this MOSFET will open, and then when this MOSFET open, then there will be a 5 volt that will basically that will be present as an output. So we checked, and then our enable signal was present, which means this circuitry was basically doing this job. So our problem is not from here because this is fine. Our problem is not from here because this is fine. Our problem was Q8060 itself. So we had to replace Q8060, and then we started to get a 5 volt instead of the 3 volt. So basically that's it, and then that will be the end of the video. The device is going to be put together, assembled, and then tested, And yeah, I'll see you guys in the next one. Thank you.